All right, welcome back. We did take a little break, but we're back at it with LeetCode 543, diameter of a binary tree. So in this problem, you're given a root to a tree, and you want to find its diameter, where the diameter is the longest path between any two nodes in the tree. So right away, I'm just going to say it, not my favorite problem. I'm not a huge fan. I think it's very deceptive to call this problem an easy. I think it's like maybe a medium, but regardless, we're not here to complain. We're here to solve the problem. So I drew out the first example they gave us here. And right away, um, we can see that in this case, the diameter by their definition is going to be 3, mostly because we can go from, let's say, 4 to 2, which is 1, 2 to 1, which is a length of 2, and then from 1 to 3, right, because we're allowed to go through the root if we decide to. It says, yeah, this path may or may not pass through the root. So this is a length of 2, this is a length of 1. 2 plus 1 is going to be 3, right? Likewise, we could do something like this. We can go from 5 to 2. We can go from 2 to 1, which is again 2. And then 1 to 3 again gives us a length of 3. So right away, we can kind of see that this problem has something to do with calculating like depth of from a certain node. And if we go back, we can kind of see that, oh, okay, well, we've done this recursively before in previous problems, right? I think there's a LeetCode problem like maximum depth of a tree. So we're kind of good on that. So if we can combine this with just a little bit of extra logic, we can kind of be able to solve this problem potentially. So right away, like let's say we start at like 1, right? Let's say we do this recursively and we go to 1 and we say, okay, well, what's the maximum depth I can get from like um let's say, yeah, from here. So if I go left, well, the maximum depth here is going to be, we know it's 2. Similarly, going this way to the right, we know the maximum depth is 1, right? And then I can just say, okay, well, what's 2 plus 1? Like, let's say I do want to go through the root that I'm calling my recursive function from. Well, I know that 2 plus 1 is equal to 3, right? And of course, we do have to think this in terms of recursion, right? So when we actually call this, for example, on the root 1, we're actually going to be calling it on, let's say we go left first, so we're actually going to be calling it on this, right? Which in turn will call it on this, which in turn will call it on, right, the null here. So this is going to be basically done in like kind of tiny little baby problems that I'm like, so we do this subtree and this subtree, right? And every single time we're saying, okay, well, what's the longest distance I can get? So like in this case, we'll consider going through the root 2, right? So the longest distance between here, well, that's just 1, but then to here, it's also 1, right? So that's a total distance of 2. So this is a little weird. Again, not my favorite problem, and I don't blame anyone for not getting it on the first try. But let's kind of try to code us up to see what we're talking about here. So like we did, we mentioned recursion. So let's just use DFS for a tree traversal algorithm. So we'll say int DFS. I'll pass in the tree node pointer root. I'll also say, right, we talked about this idea of getting the diameter here, right? So we want the diameter ultimately. So let's pass that in as well, because we know we have to update it eventually. I'll just call it D. And this is just passing it in by reference because I don't want to copy it unnecessarily. So let's get started. So easy base case, right? So if there's no roots, we'll just return 0, I think, right? Because if there's nothing there, your diameter is 0. What else? So now we're gonna get that depth. We're getting so the left depth that we're talking about. So let's do like the left depth, which is gonna be equal to DFS, right? And we'll go to the left of this root. We'll pass in our diameter for later. We're gonna say right depth. We're gonna say DFS root right. We'll pass in the diameter. Okay, well now it's time to actually update the diameter. So we're gonna say, well, D is gonna be the maximum, right? Because we do want the longest. So it's kind of a hint that you're gonna be doing something with, right, this idea of a maximum. Well, if our diameter is already the longest, right, we're just gonna keep it that. So we're gonna compare the current diameter to, right, this idea of going through, right, this idea of going through the node that we called the recursive function from. So if we call the recursive function from 1, we want to say, okay, well, how about I go to 1 and then go down here, right? this idea of going through the center. So I'm going to say the maximum between D and saying left depth plus not equals plus right depth. Cool. There we go. So we have that. And then of course, what do we return? Right. Ultimately, this is calculating, right? The DFS is returning a depth, right? It's actually not returning the diameter, it's returning a depth. So, well, how do we get a depth? Well, that's pretty easy. We're just going to return the maximum between the left depth and the right depth, and then plus 1, right? Because the recursion is coming from a parent node into a child node, so it's like going down an extra level. So we do this. Cool. Hopefully that makes sense. It's a little weird, I know. So let's define our diameter here. So we'll say d equals 0. We'll start out with a diameter of 0, and then we'll call DFS on the root, pass in d, right? And then all we have to do is return d, because since we passed it in by reference, it's getting modified in here, right? So it's getting modified in memory. So we just can instantly return. So let's run it. It works. Surprise. It's almost like I have done this before. Just to make sure. So let's submit it. Cool. It runs. Again, not my favorite problem, but let's talk about the runtime. This is O of n, right? You're linear up to the amount of nodes you have. Space complexity, also O of n. It's not immediately visible, but because we're having recursive calls, there's that implicit stack going on. So again, that scales linearly with the amount of nodes you have. And yeah, that's all there is to it. Pretty weird problem. It didn't make sense for me right away. I think if I recall doing it the first time. And yeah, I hope this video helped at least somewhat. Maybe in the future I'll make a more detailed video, but we'll see. And yeah, thank you for watching.